All right, so let's take a look at combinations of transformations. If we have a function like this, where we have f of x is equal to x squared, and we want to create a new function, g of x. And what we're going to do to this function is we're going to multiply every output by -2. We're going to multiply our inputs by 3. And we're also going to translate this function 2 units to the right. And we're going to translate it 1 unit down. We want to be able to describe the transformations and the order that we should apply them in. Transformations need to be applied in Bedmas order. So the additions and subtractions happen last, and your reflections and your stretches happen first. So the first thing that we might do here is reflect this in the x-axis. And let's follow along with Desmos, and we'll create these functions as well in Desmos. So our original function f of x is equal to x squared. Okay, so here's our original function. The first thing that we would do to create this function g of x, which is equal to, and I can just copy it down from the PowerPoint, -2, 3, copy. Actually, we want a 3f of x. Really? Not going to graph that for me? Oh, this f goes over here. That's why. There. So here's our transformed function down here. And let's see what we do to get there. The first thing that we would do is reflect it in the x and the y axis. So that would give us x negative x squared, like this. So first we can reflect it, and then we could stretch it by a factor 2 in the y-axis, like this. Next, we're going to compress it by a factor 3 towards the y-axis. So we're going to make it narrower by a factor 3. So there, we're going to have to put this x in brackets and multiply it by 3. Now it got narrower by 3. It now has the same shape as this guy. And then we are going to move it down 1. So we're going to move everything down by 1. And then we're going to move it over by 2. So to move it over by 2, I'm going to go in here, bracket the x again, and subtract 2. There. And that is so curious why that is different. Anyway, that should create the same function there. Oh, because this is not. This is there. There, that's the same. That's the same. Okay, so now this is our new transformed function. And the way we did that was we applied the transformations in this order. First, our vertical reflections, then our vertical stretches. And then we would compress horizontally by a factor 1/3. Then move it right to 2 units and down 1 unit. Notice this is right and this is down, as we were seeing before. And so this is how the order that we want to apply these transformations in. If we have a function like the parent function is the reciprocal function here, the rational function, 1/x. And if we want to obtain a new function, that's this. So here we want to be able to look at this and say, okay, this is going to be 3 times bigger. And that's going to be the first thing that I'm going to do is stretch this function 3 times vertically. And then all of my outputs are going to be higher by 2 after that. And then I'm going to move this 1 unit to the left. The order that I do the horizontal translation and the vertical translation doesn't matter, but I do have to do this stretch first. If I do the vertical translation first and then stretch it 3 times, I would also be stretching that translation. It would be now 6 units higher instead of 2. And that would be a Bedmas error working with your functions. So let's take a look at these functions as well in Desmos. Where is it? Oh, it's right there. So I have to go escape and then go in here. Here is my function is 1/x. Oops. There we go. 1/x is my parent function. and we said we wanted the function, this is 3 times that function, with it moved up by 2 and over by 1. Okay, and let's not look at that one. So in order to go from this function to this function, oh, this should be up by 2.
Do we need the double brackets in there?
Yeah, this double bracket is now no longer necessary. There we go. So there's our new transformed function. Let's take a look at the different transformations in order. So this would be the function, but stretched by a factor 3. It's now 3 times bigger in the y dimension. If I look at a single point, for example, this is the point 1, 1. We should expect to find the point 1, 3 on this new function up here. And indeed, there it is, 1, 3. We're also seeing a similar point over here, 3, 1. And that came from the point 3, 1/3 on the original function. So that's our vertical stretch. There's 3, 1/3 there. 3 and then 0.3333.
Vertical.
Yeah, so that's vertical stretch. And then we wanted to move this function 1 unit to the left. 1 unit to the left. Because when we look at this transformation, this is a movement to the left. We're adding to the inputs. That moves the function to the left, counterintuitively. So we add that inside here to x. And that's moved the function, the whole function just shifted 1 unit to the left. So you'll also notice that the asymptote now is x cannot equal -1. Because that would be like a function here. If I write this one out, this is equal to 3 over x plus 1. So there's that function. It is the new transform function. But then we also said we want to move this function up by 2 as well. So that looks like that. So that's just adding 2 to all the outputs. So there, that's the way we apply these combinations of transformations, is first do your stretches. So this is just a vertical stretch by 3. And then do your translations. When we're graphing them, one way to graph these is to first graph the parent function and then pick some points along the parent function and translate those points. Plot your new points and then put your curve through your new function. So you want to state a table of values for that parent function. Basically pick a few interesting points. You might choose the roots of a quadratic. You might choose its vertex. If it's the reciprocal function, you might take that point 1, 1 and -1, -1 and move those around. And then find the values of your transformation and then map your points according to those transformations. So actually, I want to go to Delta Math and give you a tour of the Delta Math assignment, because that's going to be great practice for applying all these different transformations. Delta Math, with its ability to give you instant feedback on this, is going to really accelerate your learning. So let's take a look at the assignment for today, Transformations of Functions, assignment 2.6. So you'll notice lots of different skills here. So there's translating functions. So this is just applying translations to functions. Here I want to recognize that I'm adding to the x by 3, and then I'm adding to inputs. So here is an addition that I'm doing to inputs. I'm adding 3 to the inputs, and then I'm adding 5 to all the outputs. So I can apply those and Delta Math says here, choose some points along here. I've highlighted the integer points for you. Translate those points. So it saves you making a table of values. So I know that all these points are going to go up by 5 because I'm adding to all of the inputs. So there is a 1, 2, 3, 4, 5 up there. But then they also move over by 3, like this. 1, 2, 3. But I don't just move 1 point. I want to move all the points. So they go this way, 1, 2, 3, and then up 1, 2, 3, 4, 5. And then I've realized, I just learned something. That actually, you just want to move the whole function, and you move that with the green one. The blue ones actually change the shape of the function. So we're all learning. So there's my new function, and that's after a translation, 3 units to the left and 5 units up. Notice how when I talk about it again, I spot my mistakes. 5 units up. There we go. So now I say submit answer. Yes, I want to submit this answer, and hooray. So this tells me shift left 3 units. That's adding 3 to my inputs, which actually moves it left. And then I add to my outputs, go up. Cool. Okay. And then you may see one type of function we haven't looked at. Okay, so here's the cubic root. Okay, these functions, we haven't looked at them, but they look like that. They transform in the same way. So here, this answer is just like this. The beautiful thing about transformations of functions, it doesn't matter what the parent function is. A, K, B, D, and C all do the same thing to your functions. They all translate them in the same way. It doesn't matter what shape that function is. So I say submit answer. Yes, I want to submit that answer. Hooray! Okay, so that's translation of functions. Next, we look at stretch and compression of functions. So here, again, another function we haven't looked at, but this function, the exponential function, is our next unit. It's unit 3. So we can start looking at it in delta math. Here, I am compressing this function by a factor 1/8. So I'm going to be pulling all of the inputs of all of the outputs of the function towards the y-axis by a compression of 1/8. So then I put that there, and that would be my new function. Submit answer. The cool thing about exponential functions is squeezing them that way is the same thing as compressing them that way. It's super cool. It's the same thing as translating them that way. Okay, so that's transformations. Let's take a look at another one. Here, we're going to be squeezing the square root function by a factor 3. That's a transformation of the output, so it's going to pull all these down by factor 3. That's going to go there. Submit answer. Done. Yes. Correct. Yay. So that's stretching and compressing functions. We also want to take a look at reflecting functions. Here, this is a reflection in the y-axis. I am having negative inputs there, so all of my inputs have flipped. It's now this function over here. Submit answer. Yes, I want to submit that answer. Hooray. And then other transformations that you'll have. Oh, this one is both a reflection in y, because I have a negative value there, and a reflection in x. The parent function here is 2 to the x. So 2 is not a stretch here. Here it's going to stretch down that way and then reflect over this way. There. It's a reflection in x and a reflection in y. Both the x and the y-axis are now mirrors for this original function. Submit answer. Yes. And of course, take a look at their explanation. Here it shows you where that transformation is applied. Negative f of x or f of negative x. Do these different things. Reflect over the x-axis. Reflect over the y-axis. Isn't it lovely? Next, I have a few of these problems that you've already started to do, a few of them. It says transform this function into that function, and it's going to allow you to test it out. So this looks like I'm going to be moving it up by 2 and over by, looks like about over by 6. So I think I'm going to be subtracting 6 from this function. And then as I do that, it shows me what that did. That looks pretty good. Then I'm going to be raising all the outputs by 2. Got it. Okay, so that's that gives you a chance to see it as it's happening and learn about those transformations. We're going to be doing multiple transformations at the same time there, so you get a chance to discover all of those. And then transformations of functions, some mixed practice here. Okay, so here we have the absolute value function, and it says compress that in the y by 1/3. So a useful point that I could take would be this point 3,3 would map to the point 3,1. And that's actually done final answer. So you submit answer. Say yes. Okay. Cool. Vertical dilation of 1/3. I say vertical stretch or vertical compression. So there you go. Multiply the y coordinates by 1/3. Done. Okay, new problem. Here is a multiple transformation. I am going to be stretching this vertically by a factor 4 and then moving it 4 units to the right. I should do the stretch by factor 4 first. So I'll take this point 2 and bring it up to 8. So there's my vertical stretch by factor 4. And then I'm going to move the whole thing over by 4. There. And then submit answer. Yes. So this is how you are going to practice with delta math. Do your stretches in the x and the y first, and then do your translations left, right, up, down. It's a great way to practice this topic. And then, of course, when you have challenging questions in here, take a screenshot, send me the question. I like the challenging questions. All right, everyone, thank you for showing up for your learning today. Please complete the transformations investigation. Bring me over when you have questions, and we will also do some review before the quiz on this topic. Bye for now.